Mr. Achyut R Kulkarni, the Applied and Unitary Stream Leader for India and the SAARC market at Trane Technologies. Mr. Achyut Kulkarni is the Applied and Unitary Stream Leader for India and SAARC market of Trane Technologies. He drives the company's AVAC sector's applied and unitary business growth. Mr. Achyut joined the company around a decade before and was engaged in various functions and projects within the organization. Before it, Mr. Achyut worked with Wipro EcoEnergy, Carrier, and Thermax. He has also participated in multiple forums like ISHRAE and Ozone Cell and represented Trane in roundtable discussions organized by Government of India related to HFC phase downs and HCFC phase out schedules. From an engineering background, Mr. Achyut is a LEED AP from US Green Building Corporation. Mr. Achyut will talk about meeting India's increasing demand for sustainable HVAC solutions. So delegates, let's welcome Mr. Achyut.
We all discussed about energy consumption, energy conservation, green buildings and all that. So I think my topic is also somewhere around it. I'll try to concise about it, and then maybe I'll try to give some more insights on that. Okay, so when we look at the energy consumption, what is the easiest way to save energy? Don't use energy when it is not required to use. That's a simple and easiest way of doing it. Second method is to save energy when energy is to a minimal extent whenever it is required to be used. I think most of the people are already following it. From the conservation point of view, I think three factors: human behavior, that plays a very important role. Technology support, I think we have all discussed about IoT and all that. So I think AI, so technology support will definitely yield us in terms of the energy conservation. And the operational practices, the after the AMC periods, and then your once you supply the equipment and then way forward, how do you maintain it, how do you operate it? So that also is a key factor in terms of the energy conservation. What are the current trends? We all speak about energy cost. When we speak about energy cost, we speak about life cycle cost, we speak about ROI. We know what is the available tool. I think just for an example, we have VFDs, we have inverter-based technologies that cater the energy reduction. Change of energy source, I think yes, heat recovery systems have come in practice. Most of the places people where they used to have this electrical heaters, now chillers are capable of delivering. The heat recovery options are available from the chillers perspective. So that is something which we have already seen. Environment, I think that's something which has been discussed a lot today. Reduction in CO2 emissions, renewable energy. When we look at the options available, HFC phase down, that's something which is going on right now. What is next? The low GWP refrigerant and the natural refrigerants, what we go through. We have regulatory norms, we have ECBCs, ASHRAEs, energy codes, energy labeling, and then not sure much about the tax incentives, but I'm pretty sure that going forward, we will come across good amount of tax incentives coming in from the HVAC perspective. Most important on the efficiency, we all touched upon the system approach. Okay, the climate change, we all spoke about it. This is the COP27 that happened in Egypt. We all know it is to limiting the temperature increase to below 2 degrees. That's what the motto is, and recognizing 1.5 degree as a goal, so which a lot of organizations have already taken it, and then they are marching towards it. One of the steady recent survey I was just browsing through, and then I got it. We have seen as per the latest survey, 51% of the respondents say that environmental sustainability is more important than today, as when you compare it with 12 months ago. I think, as I said, most of the people are now looking towards environmental sustainability as a practice. That's something change we are looking at, and 49% of the consumers say that they have already paid premium, because we know the new technology, whenever we have a new technology, when we have a new product line coming in, it comes with certain amount of cost when you compare it with the traditional one. Yes, they have said that they are ready to pay, or they have already paid premium for procuring the most energy sustainable products. Emissions, when we look at it from the HVAC perspective, we all know 15% do come from heating and cooling buildings, 10% do come from the food loss, and the overall greenhouse gas emission combined share, if you look at it today, we stand around 25%. And if we don't have a proper action, then we'll not be able to address the energy efficiency and energy demand for space cooling, which we know that it's going to grow by triple in terms of 3 times by 2050. Just a bird's view, I think I've picked up this from the ICAP. You see the growth in terms of the space cooling, cold chain and transport. I think the growth, what we see, the max is towards the space cooling. I think that's something is been picking up, and then we have seen a lot of projects. In fact, when we look at the business perspective or the market perspective in terms of the HVAC today, I think the market is growing way high. I think maybe COVID has impacted a bit, but I think now it has been recovered, and the growth is also pretty faster. And when we look at the floor area and air conditioned area, you see they are all growing in parallel. it means that today air conditioning is not a luxury anymore. It's become more of a necessity. Just to touch upon the Kigali Amendment, we all know 2016 we were all part of the Kigali Amendment. India also ratified this agreement, and then we fall part of A5 Group 2 party, and then we have a target of reduction to 15% by 2047. I don't want to touch more on this. This is the projected cooling and HFC demand. If you look at it, I think this slide itself is so big. In fact, when you look at the right hand side, the way it is progressing, and then the way how the India Kigali Amendment allowance is available for us. So this is something which is alarming. I think we need to act fast and look for more sustainable options, because we have the growth and we need to adopt the new technology in order to limit the emissions moving forward. Okay, just a small perspective I picked up from the IOP Science magazine in terms of the HVAC HFC refrigerants what we use today. 73% of the HFC refrigerant goes for air conditioning, and 27% of the refrigerant go for refrigeration percent. When I further split it, the maximum share is to air. When I speak air to air, is all about our ductables, VRF, split units. I think they have the maximum share of 38%. Mobile air conditioning, particularly the car air conditioning and the transport air conditioning, contributes to around 28%. Right now, the chillers is somewhere around 7%. And then similarly, if you look at the split for refrigeration, small and large refrigeration 11%, foaming agents is around 15%, and cold chain is around 1%. Where are we and where are we going? Past, we all know we had all the CFC based refrigerants, which we don't talk anymore. Then there were transitional, we had HCFCs in between, and we are having HFCs right now. Even HCFCs to some extent, we still see some of the HCFC products like R22 split units and all that in practice. Maybe in tier 2, tier 3 cities, I have seen in many places people do sell these units, but they're all transitional. We all know we have deadlines for it, and government is already putting up plans. The HPMP stage 3 plan is coming in practice, wherein they are now going to completely eliminate these HCFC refrigerants. Through Kigali, we also have a cap on HFCs. Now, what's next? The HFOs. So that's something which is the talk of town today, which is called as hydrofluoroolefin based refrigerants. We have multiple refrigerants, and today a lot of people have started adopting this new technology. And as a mandate, people do say that I want to switch to the new and the most environmental stable refrigerant based products. Balanced approach, as I said, 5 pillars. The next generation refrigerants has to be on this. One is the ozone depletion. It has to be zero. You cannot compromise on the energy efficiency. Maybe it is an HFO, but the efficiency of that particular refrigerant, if it is too bad, then it's not going to help you. The emissions is something which is very, very important. What is the refrigerant emissions we have? Global warming, which we all talk about. What is the current global warming levels, and atmospheric half-life? For me, the global warming and atmospheric half-life is pretty important, because today the HFO-based refrigerants, the global warming potential, what we see in these refrigerants today is somewhere around 2 and even 1. And when I say half-life, the atmospheric life, it's around maybe 20 days, 22 days, or maximum 26 days. When we compare it with the traditional HFCs, the HFCs-based refrigerants, the global warming potential we have seen close to 2000, 2500 and all. And 134A, when we speak about, it's around 1400. And the half-life is close to 13 years, 20 years, like that. So the next generation refrigerants definitely have a very, very minuscule global warming potential, and the half-life is also countable. It's just in days. Okay, how we are planning it, or how the most of the companies are planning it. A lot of people have taken this. They call it as a gigaton challenge. Some of them called it gigaton challenge. Some of them called it a metric ton, 100 metric ton challenge. They have different names, but most of the companies are going towards it. And it's not just by saying there has to be a validation based on it. Like say how we spoke about MNV, measurement and verification. There has to be an agency who will measure and verify whether you're really marching ahead towards your commitment and towards your challenge. So SBTI, it's a science-based target setting. There's an agency, it's a consulting agency who do monitor, who do work with the industries, and then make sure whether whatever challenges they have set forth, whether they are on plan or they are going out of the plan, or whether they have any challenges. So we as Trane have already tied up with SBTI, and then we are working with them. And then for us, it's the gigaton challenge. We want to reduce 1 gigaton of carbon emissions from our customers' footprint by 2030. So if you look at the SBTI based initiative program, almost 4,000 plus companies have registered, and then they've started taking actions. 2,078 companies are already registered with them, and around 1,562 companies have already registered with net zero commitments. And when we look at it, what 1 gigaton is all about, it could be the annual consumption of emissions of Italy, France, and UK combined. So that's the value in terms of the carbon emission. And a lot of companies, it could be Walmart, Cisco, Microsoft, Amazon, IKEA, Unilever. When you look at the Indian companies, I could find Bharti Airtel, ACC, Godrej, Tata, Mahindra, and many companies from India also have registered with the SBTi program, and then they are working towards this reduction in the carbon emission. Second point which we all spoke about is the system-based approach. I would just like to touch upon the system-based approach. It's not just the one equipment, like what we heard Mr. Anish also on this. It's not just the best chiller plant. It's not just the best equipment. It has to be the system, because you may have the best chiller, and if you don't have the right cooling tower, the right pump, the right controls, the right pumps in it, and if you don't have a MNV, which is measurement and verification, then the entire system will collapse. So it's not about the high performance chiller, it's about the high performance chiller plant. Most of the time it is, when people say that, okay, what is the bid and then first cost or the operating cost, when you look at the life cycle analysis, you will find that total energy or the money spent, maybe 10% is towards the life cycle cost and 90% is towards your operation and maintenance. The product what you buy, maybe it constitutes only to 10% of the value, and then 90% goes how you operate and maintain it. A lot of publications are available. This is one of the publication called HVAC Green Guide. It's not the 90.1, it's a separate from 90.1, but it gives you a lot of ideas, it gives you a lot of information on how to maintain a proper energy efficient plant. It also gives you what should be your traditional chilled water temperature or condenser water temperature, what should be the flow rates and all. So this green guide is something which is available. We have a lot of information available today, and which can be implemented and make the building more sustainable, make the building more efficient. In fact, recently the ASHRAE 90.1 also came up, because traditionally we have seen, when we look at the evaporator, we always say 2.4 GPM per ton. That's the standard that is being set. But it's not necessary that we need to run the chiller at 2.4 GPM to achieve one tier of capacity. So it says that you can increase the flow rate and decrease. You can increase the flow rate, and you can decrease the flow rate and increase the delta T, so that you reduce the pumping power, you reduce the pipe sizing, you reduce the power saving, everything that comes when you go for a small and a minimal change in your design. Some of the ductwork, which whatever we have seen in most of the plants, most of the times we see the bends are 90-degree bends. I think why not we work out wherever there is a space available, we can have 45-degree bends instead of 90-degree bends, because the pressure drop on across the pump will be lesser, across the chiller will be lesser, so thereby reducing the pumping power. So these are some of the illustration what we have seen in some of our plants. 90-degree turns, I think raised foundation, I think this is one of the best way. If you have a pump, instead of putting it on the ground and putting two 90-degree bends, why don't you raise the foundation and then put a pump, so that it is just one go. It also helps you to reduce your pressure drop as well as increase your efficiency levels. Some of the cases where we have done some of the retrofits, where we have seen wherever possible, it may not be possible, space is a challenge, we know we have a lot of issues with the space, but wherever we have a possibility, I think we can look into this kind of options. Okay, optimization controls is very key. I think it's not just the chiller. Again, I said it's all the complete system, and most important, what is putting them all together is your controls. I think we discussed about controls also. I think not much, and in India, what madam said is true. Chalta hai attitude. A lot of the people say, if it is not working, bypass kar do, chalao plant. So that's something which we see more often, but it should be avoided. And I think we need to educate people on this and make sure that the chiller plant controls are optimized and working fine. Some benefits of the low flow design, which I just spoke about, it could be reduction in capital investment, reduction in running costs, pumps, motors, piping, valves, insulation, ducting, so on and so forth. And like what sir said in the last slide, what that half degree means, we all speak about half degree. I just got this one simple page article in Times of India sometime back, and then I thought, I think this is very informative slide. I don't want to explain this. I think it is self-explanatory side. Why this 1.5 degree reduction, and what does it mean for us? So this is how it impacts us. Okay, I think that's it from my side. Thank you.